Okay, so a couple things I wanted to go over as you guys have seen this new assignment, this assignment 2. One of the things that it asks you to do is make some JUnit test cases or write the test cases for the assignment for the edge cases. We're talking about the boundary test cases, writing test cases for boundaries. Sorry. There are a couple of things that I wanted to talk about in regards to the test cases that come up, especially when we're talking about Java or anytime. One of the cases is going to deal with specifically when we deal with object-oriented programming that has exceptions that we have to deal with. The other thing is kind of a general programming issue with how floating point numbers, decimal numbers, are treated. So let me go ahead and share my Java stuff. Here we are. Okay. All right. So, and let me go and make it a little bit bigger so you can see settings. It's under font. And make it bigger so you can see. Okay. And as you can see down here, I've been playing around with it already. So preparing for today's stuff. Okay, so this is what we have. We have a situation where basically a very specific, just a simple example of two methods that we may have been asked to write for some reason. Right? So one, this idea of the total payoff. The idea is when you pay off a loan, you pay back not just the amount that the loan was for, but there's also interest involved, right? So like if you take out a loan for, a house or a car, or sometimes if you have a friend that wants to charge you interest, like don't keep hanging out with that friend, I guess. I don't know, but anyway, you'll pay back a certain amount over a specific number of months and the total payoff. Now, the way that we have chosen to do this is that we basically take the total and we add to it the payment. We add to it the payment for however many months there are. Yes, the much easier way to do this would have been simply to return return payment times months, right? Like, I mean, yeah, that's really what it comes down to. But the reason why I did it this way was because there's this little tricky thing that involves floating point numbers, right? So if I were to do a main method, I should have written this already. I didn't realize I was going to do this example. And if you were to say, let's just do a total like this. Double sum equals 1.0 or int I equals 0. I is less than, let's just do it like 10 times so we can see what's going to happen. Okay, so we're just going to loop through, and each time through, what we're going to do is we're going to do two things. One, we're going to say system.out.println sum. We're going to print out what the sum is currently, and then we're going to do sum plus equals 0.1. So we're just going to keep adding 0.1 to it. So what we should see is 1, 1.1, 1.2, 1.3, and so forth. All right, so if I were to compile this and run it, assuming this works as I expect it to. Yeah, there's the problem. Okay, so what you'll see is, so first time through, 1. Great, that's what we expect. Then we add 1 to it and we get 1.1. Great, that's what we expect again. Then we add 0.1 to it. We would expect to see 1.2, but we actually see this. Wait a second, how did that happen? It's all about how floating point numbers are represented in computer systems. Okay, and I don't want to go through all that now. If you need a refresher on digital systems and computer architectures and computer organization, we can talk about that some other time. But basically understand that the problem is that if I were to try to say, okay, if sum equals, like at the end here, after we add one, I'm expecting for sum to equal, right, 2, right? So if I were to say system.out.print line sum, and if I were to say if sum equals 2.0, system.out.print line. I'm going to also print correct. Okay, so what we're basically saying is if it equals 2, I want to print correct. Now what we're going to see is when we run this, correct doesn't get printed. And the reason why is because sum is not 2, but 2.000000001. Now, you and I can look at that and say, wow, come on, that's close enough. That's practically 2. But the computer doesn't see it this way, okay, because of the way it's represented. For integer values, this is okay. For integers, you know, to say, if I keep adding 1 to things, it always is the same. Because of the way integers are represented in computer systems, that's okay. All right. So the reason why I'm going through all this is we are going to add some double value to a double variable over and over again, and we're going to return whatever that total is. It might not be exactly payment times months. Okay, so we need to figure out how can we say, you know what, for all practical purposes, this should be treated as if this was equal. Okay, so we have to figure out how to do that. 1. All right, so that's one special case. The other one is this. Okay, it's basically a method that if A is divisible by B, then it returns true. If A is not divisible by B, it returns false. Okay, so then the question is here is if B is 0, this method, this operation generates an exception, but we want it to. We want this to generate an exception. So one of the tests that we're going to need to do is we're going to need to test and say, okay, how do we test to make sure that an exception happened? Right? Okay, so those are the 2 things that we need to talk through. Okay, 1, how do we test for a double value that's close enough? We want to make sure that it's close enough. All right. Second, how do we test for an exception that occurred? All right. So the first thing I've done here is I've created a test case. Now in JGrasp, if I create a test case file, I need to put both of them together into a project. So the way you would do that is project, new project. You would add both of them to the project. Okay. So now, the way that asserts work, so in a JUnit test suite, you're going to have a set of assert statements. So here we're saying assert, and I'm going to put it down to a new line to make it more easy to see, is assert equals, and then we give it some message, okay, and then we give it a value, and then a value to check, is that equal to it? So let me give an example here. Oh, by the way, when you generate this test suite, what's going to happen is it's going to generate a test that always fails. And what it'll do is it'll give you something like this. It'll give you 0 and 1. Okay, so basically what this is saying is if this equals this, do nothing. However, if this does not equal this, generate an exception, an assertion exception. Okay, so we compile it. Okay, and we run it. Okay. Notice that this test default that always fails, it failed. It failed when we ran it. That's what we expect, right? Because we expected 0 but got 1, so something ain't right. Something's not right. Okay, so these do not equal each other. Again, with if statements, sorry, with integer values, we can do this because of the way it's stored. We could also do this with I'll do this with Boolean values, right? It also failed because we expected true but got false. Okay, this is the value we expect to get. This is the value we got. Okay, so so when we come to this one, so now I'm going to comment that out because I don't want the test that always fails being part of my test suite. Okay, so here we send it 1,000 as the payment, 12 months as the number of months, and we expect to get 12,000 back, right? But if I run this, it's going to fail, and not necessarily for the reason you might think, because it is the value is not right, but it says here, right, is that we should use this expected actual delta. Now, what is delta? Well, okay. Delta is another value that we can give it that we say as long as it's within this certain amount. So 0.00001, for example. Okay. Then what that's saying is that as long as this value is within 0.00001 of this value, treat it as if it's right. Treat it as if it works well. Okay. So if I go and compile this and run it. Okay. Now notice now it passes, right? Because it was within that value. So if I were to say, go back to here. So if I were to say, okay, well, let's force it to be not right. Let's force it to be okay. So now we're going to say, as long as this is equal to this within this range, then we should pass it. And I'm expecting it to fail now. Yep, so there you go. Expected 12,000, which was the first value, which is what the method returned. And I got this instead. So that's not right. Okay. All right. Another way we can do this, an older way that we could do this if we didn't use the, if you're using an old version of JUnit or some other testing things, so we'll call this test 1A, is what we could do is we could say, okay, double return value equals, and we go and get that. Okay. And then we could say double epsilon, which is like the delta, which is the basically the amount of error that we will accept. Okay, so we give it that value. And what we then say is we take the return value, whatever it is, we subtract whatever value it is that we expect to get. Okay, so if return value is a little bit above, then it'll become a very small positive number. If the return value is a little bit below 12,000, then it'll be a very small negative number. So what we do is we wrap that in a absolute value method. Okay, so now what do we have? We have some really, if return value is correct, all right. If return value is the correct value we expect to get back, then this minus this absolute value will be some really small positive value. Ideally less than this. Okay. So what we say is, if as long as it's less than epsilon, if it's less than epsilon, if it's less than that small tiny value or delta or whatever you want to call it, then what's going to happen is this is going to be what? If this is really small, smaller than this, then what's going to happen? It's going to be true. All right, so we say as long as that's true, then we're good to go. Okay. So we should get a passing test case on this now. And there you go. It's passed. Yep. Okay. And this keeps coming back over here because what test is still failing is one that I'm going to show you in just a moment. Okay. You could call it epsilon, like I said, you can call it delta, and then you could, you could even just say right, give an expected variable value here, and then what you end up with, and then it becomes, it doesn't matter which side is on this, which side of the negative, the minus sign here, and then this way, what you can do is just throw this, change this up here where it's easy to change it rather than trying to go down into here and do all that mess. Okay, all right, so that's that. So that's how you test for double values. You can't, with integers, you can test if they're directly equal, that's fine. Doubles, floats, you can't do that. So this is how you have to do that. All right, so let's take a look at the is divisible method. So for something like 2 and 3, yeah, we expect that to be good. We expect it to be false. Let me give another one here. Let me give one that should be true. We'll call it 2a. Remember, this and this, none of these can have the same name. We cannot overload these methods. It's not possible. Okay, so if you did 4, or actually let's say 6. Okay, so 6 and 3 should be true. All right. So, but here, what we expect to happen is an exception. But the way that these test cases fail is by generating an exception. So if an exception happens, any exception. So for example, let me just give you a couple of simple examples. I'm going to call this test case X and test case Y, and we'll call this always fails, and we'll call this always passes. Okay, always fails. All we have to do to make a test case fail is throw an exception. No matter what, this test case will fail because an exception was thrown. All we have to do, make sure a test case passes, just don't do anything. As long as an exception doesn't get thrown, nothing's going to happen. Here, wait. Let's see. Oh. Throw new exception. Let's see. I think because it's a checked exception. There we go. Okay, so if we just throw a new runtime exception, boom. All right, always fails, always fails. It's just because an exception is thrown, that's what is the definition of failing for a test case. Always passes, always passes, because no exception was thrown. Okay. All right. So how do we check if an exception was thrown? We want an exception to be thrown, but the problem is the reason why this fails is because an exception was thrown and we didn't catch it. All right, so this is how we can do this. Okay, we can say try, and then we want to try the thing that's going to cause the exception. So this is what we're going to do. We're going to throw this into here. Okay, and we expect this to throw an exception. All right. So we want to catch that exception, right? And if no exception happens, right? If no exception happens, sorry, if an exception happens, then this will effectively do nothing, right? Which will pass the test case. Oh, where are you? Where are you at? Who am I missing? What am I missing here? Oh, I forgot to close. Forgot to close curlies. I always do that. Okay, so now when we run this, now notice that, okay, always fails, still always fails. That's fine. That's what we expect. But this is divisible to 3 passed now. Why? Because the exception that was thrown here got caught. Now, what kind of exception got thrown? A divide by 0 error. Now, we could say that. We could say, so let's, let me throw this off because I want to, what's going on? Oh. So let me try throwing this and then seeing what the specific name of the exception is divisible arithmetic exception. So we could specifically say we want to make sure that that particular, because right here, any runtime exception that gets thrown will get caught and told that the test case passed, right? But we want it to be an arithmetic. Right? We want it to be an arithmetic exception. So when we run, it does pass. Okay. Now this test case, actually, there is still one problem, and that is, what if this happens? What if we say, what if we just say return true? Right. Okay. Now, when we go to run this, right, that is divisible 3, it passed. But wait a second, it shouldn't have passed. This should not have passed because an exception wasn't thrown. And the reason why, I'm gonna go and undo my changes here because I do want this to run correctly. Okay, the reason why was because we caught the exception and we never threw an exception if the problem happened. So what we can do is we can do this. We can just assert. We can. I'm gonna actually just use this. And we can say just assert true equals false, right? Because what does that do? That definitely tells me that failed, right? So it's basically, if we get to this line, then that means that we executed this line and did not generate an exception, right? And so then if we get to this line, it means the exception that should have happened here did not happen. And so now we will automatically give an exception through an assertion, right? That will then say, hey, you failed that test case. Okay, so if I run it, okay, and one thing I'm going to do is I'm going to go change my code, right? Because here, let me take this one out because I don't want a failing test case in here anymore, because I want to show you what happens when you run a set of tests and they all pass, and it's the feeling, the joy that comes from running this and seeing all 6 tests passed. Yeah, they're all passing, all green, everybody's happy. Okay, because let's say we go back and we take this. What are my 2 other examples here? 2 and 3 and 6 and 3. Okay, so we will say we're going to change the code here. If A equals 6, turn true, else turn false, and we'll just say that's it. If A equals 6, return true, else return false. Okay, so compile that. Now you hopefully know that this is not correct, but what we're going to see is we passed this one. We passed this one. What were those two? We passed these, right? We passed this and this because they did what they were supposed to do. The one we failed was this exception, right? And this is part of why I keep saying over and over again, we cannot test all possible inputs, and we can't test completion, right? Because here's the thing. I could even do this. I could say if B equals 0, throw new arithmetic except. And now when I compile it and I run it, what happens? All of them pass, right? But is this correct at all? No, right? So all the test cases pass, but clearly the code is not correct. Okay, but all that's to say is we cannot test to prove correctness, but we can test to find problems. And so what I would suggest is so in these test cases is coming up with a few others that are where the B values are different, the A values are different, right, and stuff like that. Okay, so but mainly what I wanted to help you understand was two things. One, how to test for equality when it comes to double values, and then also how to test for that an expected exception actually gets thrown. Okay. All right. Now, one other thing, we can change this to just correct to say catch exception. Now, if we do that, what's going to happen is that when we go to run this, it's going to pass. It's going to pass because the thing that got thrown was an arithmetic exception, which is a type of runtime exception, which is a type of exception. So, but the problem is that we may throw some other type of exception in our code down below, but we may still catch it and erroneously think that the correct exception was thrown. So when we write, there we go. When we write test cases to check for exceptions being thrown, we should make sure that we specify which exception to the lowest level that we can, which exception actually got thrown. Okay. All right. So I hope that's clear for everybody. I'm hoping that that helped you out, and we will. Good luck on the assignment. I hope that clears up, helps you understand how to write some of those test cases. All right, thanks guys. Have a good weekend, and have a good have a good afternoon. Have a good weekend, and I'll see you next week. And a happy New Year. Mutlu or Yobashana Kutulolsen. All right, and I'll see you guys after the first of the year. And I'll see you in 2021.